Okay, in this next example problem, I'm going to look at problem 10 here on this exam page. And basically I've got two routers. I've got two local area networks off of router 1, one local area network, well, two off of each, and then one of them contains servers, the other three contain hosts. Okay, and so the first question is to write down the subnet IDs for each of the 5 subnets and indicate which host devices are on each subnet. Okay, so basically, when you look at a diagram like this, sometimes it's not necessarily clear whether they're giving you host IP addresses or they're giving you subnet IP addresses. And we have to kind of figure that out here. But they are labeling individual hosts, so there's an address for each host shown. So that gives us a hint that it might be giving actual host IP addresses. And so what we've got to do is we've got to figure out what the network subnet IP address is for this. And so what I'm going to do is I'm going to take, first of all, I'm going to take the /26 and I'm going to say that that means 26 is equal to n plus s, and therefore h is equal to 32 minus n plus s, or 32 minus 26, or 6. Okay, and where an IP address is broken up into 3 parts: a network, subnet, and hosts. And the sum of these 3 numbers is 32, because each of them is giving the number of bits in these respective parts of the IP address. So I have 6 host bits, and therefore I have, for a /26 network, I have 2 to the 6th, or 64 IP addresses, okay, per subnet. And so those subnets are going to be the following. If I'm at 192.168.75.50, I'm going to have subnet addresses 192.168.75.0.64.128 and .192. And so these are going to be the 4 /26 networks in the 192.168.75 Class A network. And so the question is now, which of these 4 subnets are these 2 hosts in? Oh, shoot, you can't see it. Sorry. Okay, there you can see them now. So those are the 4 subnetworks. And so you can see that these 2 host addresses, 50 and 51, are in the range from 0 to 64 here. And so for hosts A and B, the subnet address, the subnet ID is 192.168.75.0/26. Okay. Now you can immediately see for hosts C and D, they're in the same class A because it's a .75 here, same .75, but their host number is 65 and 66. And so the question is, which of these 4 ranges? They're also in the same 4 ranges, and you can see that it's range number 2. 64 is the subnet ID, and then 65 and 66 happen to be the next 2 addresses up. So hosts C and D have a subnet ID 192.168.75.64/26. And let's look at hosts E and F now. Hey, they're in the same class C, 192.168.75, and now their addresses are 202 and 203. And so again, the question is, so because they're in the same class C, now we can look at these four class C / 26 subnets and ask which one are they in. And addresses 202 and 203 happen to be in the range from 192 up to 255. So they're in the 192 subnet. E F dot 192. Okay. Now, what about these two addresses? These two addresses, .8521 or .8522, are on a /30 subnet. And /30 subnets are the smallest ones. So let's look at a /30. 32 minus 30 is equal to 2. In other words, that's equal to H. In other words, 2 to the H, or 4 IP addresses. Okay, so this is the smallest sort of practical subnet because 2 of the IP addresses are used. One is used for the subnet ID, the second one is used for the broadcast address. So there's really only 2 addresses that are usable by hosts in a /30. Well, that's all we're using here. So we have 192.168.85.21 and .22 here. And so the question is, what subnet do these lie in? And the same way that we counted by 64s up here, we can count by 4s here. So we have a 0, 4, 8, 16, how about 12, John? 16, 20, 24, etc. And so these ranges of IP addresses, and we see that 21 and 22 fall in the range from 20 to 23, which is this 20 in the last octet. So the serial lines S00 for router 1 and router 2 S00, they're on subnet 192.168.85.20. Okay, and they are those exact 2 addresses which are in the range from 20 to 23, but 20, 21, 22, 23, 20 is the ID and 23 is the broadcast. Okay, so these are the available IPs in that subnet. Okay, and a /30 is you know, commonly used for this type of connection because this is a serial link that is a WAN connection, something like a T1 or a T3 line between 2 router interfaces. So we only need 2 IP addresses there, and that's a /30 is useful for that. Finally, the servers, let's see, they're on the .65 in the 3rd octet, and their addresses 98 and 99 on the .65. But these are on a /27. So the /27, let's just do it down here. Maybe we'll divide this up so we can see what we're doing. /27, 32 minus 27 is 5, right? So H is 5, and we have 2 to the H, which is 2 to the 5th, or 32 IP addresses in these subnets. And so they start with values. The 4th octet is 0, 32, 64, 96, 128, 1 160, 192, or 224. These are numbers that should be familiar to you from subnetting. And so the question is, where do the 98 and the 99 lie? They happen to lie between 96 and 127. Okay, so the subnet ID for these two guys is 192.168.65.96. Okay, oh, there it is, 65.96. And this is a /27. Okay, so that's how you do part A of this problem. Basically, I'm just figuring out these 5 subnets here. Okay, hope that helps. And I'll do parts B and C to this problem in the next video.